Hello and welcome to my mathematics tutorial where I will be guiding you through the Heiss Mathematics Textbook 3rd edition. In this unit, we will be learning all about quadratics. So to begin, we will talk about exercise A and I will guide you through, and hopefully things won't be too hard. So let's get right to it. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, c are constants and a cannot be equal to 0. A quadratic function is a function of the form y equals ax squared plus bx plus c, where a cannot be equal to 0. If a equals 0, then this wouldn't be a quadratic function, it'd be a linear function instead. A quadratic belongs to the family of polynomial functions, in which they can be linear, quadratic, cubic, or quartic, depending on the power that x is raised to. There are a few ways that we can solve quadratic equations, such as factorizing the quadratic and using the null factor law, completing the square, we can use the quadratic formula, or we can use technology, which means using a graphing calculator to find the answer. The solutions of ax squared plus bx plus c equals 0 are values of x which satisfy the equation or make it true. In this example, when x equals 2, this equation is validated. So x equals 2 is the root of the equation of x squared minus 3x plus 2 equals 0. We can solve quadratics by factorization. First, we can rearrange the equation so one side is 0. Then we fully factorize the other side. We can then use the null factor law to split the factors into linear equations that are equal to 0, and then we can solve the resulting linear equations. Be careful though, avoid dividing both sides by any expression containing x. This will prevent you from losing any of the solutions. This example shows that you might lose one of the solutions if you divide both sides by x. These examples are showing how factorization can be used to solve quadratic equations. In example A, since already all the terms are collected to one side, we can then factor out x, and then using the null factor law, we can solve for x. So x equals 0 or 3x plus 5 equals 0, and solving for x, we get that x equals 0 or x equals negative 5 over 3. Similarly, in example B, we can put all the terms to one side and then factorize, and then use the null factor law again to solve for x. In case you were confused on how we factorize in example B, there are two numbers that multiply to negative 6, and the same two numbers add up to negative 5. In this case, negative 6 times 1 equals negative 6, and negative 6 plus 1 equals negative 5. So the two numbers are negative 6 and 1. In these examples, the x squared term has a coefficient that's not equal to 1, and so different factorization rules may apply. First, make sure to move all the terms to one side. Remember that these quadratics are equivalent to the form ax squared plus bx plus c. And so in these cases in which the coefficient of x squared is not 1, you have to know that there are two numbers that multiply to equal the product of constant c and constant a. These same two numbers must add up to the middle constant, the constant b. So let's look at example A. So here, after moving the terms to one side, we have 4x squared minus 4x plus 1 equals 0. We also know that there are two numbers that multiply to equal 4, because a times c, which is 4 times 1, is equal to 4. But at the same time, these two numbers must also add up to the middle term, which is b. And in this case, b is equal to negative 4. So these two numbers must add up to equal negative 4. So which two numbers do that? It appears that both numbers in this case are negative 2, since negative 2 times negative 2 is equal to 4, and negative 2 plus negative 2 is equal to negative 4. So, in this case, we can rewrite this quadratic again as the following. So this gives us 4x squared minus 2x plus 1 equals 0, which is equivalent to the expression we had before, except that the negative 4x is split into two negative 2x's. Now we can factor out 2x from the first two terms and negative 1 from the last two terms. So it gives us the following. So now in this step, it seems that 2x minus 1 is a common factor. So we can factor out the parenthesis of 2x minus 1. And that gives us 2x minus 1 times 2x minus 1 equals 0, which is equal to 2x minus 1 squared, because there's two of them. So now in this step, you can solve the quadratic like you normally would. In this case, you can square root both sides, and we discover that x equals to 1/2. So here in example B, I did the full factorization of the expression, so just to make sure that it makes sense. So in example B, we did the same thing. We brought the terms to one side, we then factorized, and then we used the null factor law to set both linear expressions equal to 0, and then solve for x that way. So in this example, we have x as a denominator in the fraction. So in order to get rid of that, we have to multiply both sides by x. And you guessed it, we do the same thing as before, make sure all the terms are on one side, and then factorize, and then use the null factor law to solve for x. If factorizing quadratics by now still seems a little bit iffy or confusing, I've left a couple links that will help you with that. So be sure to check that out in the description below. Alright, moving on, the next section, solving by completing the square. So as you know by now, not all quadratics can factorize so easily, and in this example, x squared plus 4x plus 1 cannot be factorized by simple factorization, and so we have to use different methods, and that is completing the square. Factorizing quadratics using this method enables quadratics to be turned into the form x plus p all squared equals q. And from here on out, we can solve for x very easily. These examples are pretty straightforward. So in both examples, we can start by square rooting both sides to solve for x. Note that in b, we cannot square root a negative number. So in example b, there's no real solutions. In example 5, we want to convert this quadratic into a perfect square, which is basically in the form x plus a all squared. And we can do this because the x squared coefficient is 1. So let's say we have a general example of a quadratic, perfect square, that's x plus a all squared. And so expanding it, you get x plus a in parentheses times x plus a in parentheses, which equals x squared plus 2ax plus a squared. So we want to convert it back from the expanded form to the more condensed factorized form. And the way of doing that is, so like in example 5, we have the expression, all terms on one side equals 0. So in this case, we want to make sure that all the terms that contain x stay on one side, but all the constant terms are on the other side. So that's why we bring the 1 from the left side to the right side. Notice that the expression on the left now, which is x squared plus 4x, is similar to the general expression that we derived, which is x squared plus 2ax plus a squared. Now let's look at the coefficient on the x term. So in this example, it's equal to 4. And in the general example, it's equal to 2a. So in this case, a is going to be equal to 2. But notice the third term on the general quadratic. It's a squared. So we got to take what we got for the value of a, which is 2, and we got squared. So 2 squared is equal to 4. But remember, what you do to the left side, you must always also do to the right side to make sure that both sides balance. So in this case, we're going to add 2 squared to one side, but 2 squared to the other side. So this now gives us a quadratic, perfect square quadratic on the left, and a numerical value or some value on the right. So we just completed the square on the left side, and that can be converted back to the form of x plus a squared. So in this case, a is equal to 2, so the left hand side is going to be equal to x plus 2 all squared. So now you can solve for x by square rooting both sides, but don't forget that you have to include the plus or minus square root of the right hand side, because in this example, plus or minus root 3 squared is going to be equal to 3. This goes for all scenarios except the ones where you have a negative number on the right hand side in case there's no real solutions. In example 6, we can complete the square to solve the quadratic, but first we must divide both sides so that the coefficient of the x squared value is 1. So in this example, we divide both sides by negative 3 and then complete the square as normal. A useful tip to know after putting the constant on the right hand side is that the constant term that you're going to add to both sides is just going to be the same as taking the coefficient of the x term, divide by 2, and then squaring it. At this point, if completing the square is still too difficult to understand or grasp, then I have links posted in the description below that will help you with that. The last method we will talk about in this video is the usage of the quadratic formula. So the quadratic formula states that if ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. You don't have to memorize this formula. This formula will be given in your data booklet. Still, I would recommend you to know it because once you do more quadratic problems, this formula won't be too difficult to memorize or know. This screen shows the derivation of the quadratic formula. So let's say you have a general quadratic formula in the form ax squared plus bx plus c equals 0. We can divide both sides by a and then move the c over a to the right hand side. We can then complete the square by adding b over 2a all squared on both sides, which yields x plus b over 2a all squared equal to b squared minus 4ac over 4a squared. So now you see the quadratic formula come into shape. We can then square root both sides by taking plus or minus square root. And then we can finally move the b over 2a on to the right hand side. And voila, it actually works out so that we get one single improper fraction. So in the next example, I don't really think I have to explain much. You basically just plug into the quadratic formula. Just be careful with negative signs and you should be fine. Just plug and then solve. Also, one thing is that you should note that before using the quadratic formula, make sure that all the terms are on one side so that right hand side equals 0, because the way we did the derivation earlier said that ax squared plus bx plus c equals 0. So to make sure that this works, make sure that all the terms are on one side. So yeah, one thing I forgot to mention, a little bit using technology. It's not very difficult. All you have to do is use your graphing calculator. If the right hand side is 0, then you can graph the expression on the left and the solutions will just be the x-intercepts. If the right hand side is not 0, you can either rearrange the equation so that the right hand side becomes 0 and then graph the left hand side expression to find the x-intercepts. Or you can graph the expression on the left and the expression on the right, so you have two equations, and then see the point where they meet. The x-coordinate at that point is your solution. Note that you might have more than one solution because there might be more than one intercept point. So that's it for section A of quadratics. I'm sorry if this is a little long because this is my first tutorial that I've made. If you have any questions, feedback, I'd really appreciate it because all I want to do is just help out more IB students who are going through the same struggles as me. I know that there is a lot of work that goes into each of the IB subjects, and I hope through my experience that I'm able to help more people, especially to those who are struggling. So that's why I want to make things as clear as possible. My background is that I've just completed all the exams yesterday, and so I am still waiting for my IB results. But in the meantime, I want to record some more tutorials to perhaps help future students. So let me know your thoughts and opinions in the description, and I shall see you in the next one.